The Swedish construction sector generates over 500 billion kronor in annual turnover. Despite this massive scale of capital and material moving through the economy, less than 15% of the industry's core workflows are digitized. The operational foundation is fracturing under its own weight. To manage a single site, the average small to medium enterprise relies on a chaotic stack of disconnected software. They use BigNet for project planning, Fortnox for accounting, and TID-Report for time tracking. Safety rounds and incident reports are isolated in PDFs, while crucial ATA change orders live in spreadsheets that go out of date the second they are saved. Because none of these systems integrate, data becomes permanently trapped. Time logged in the field never reaches the invoicing software automatically. Near-miss safety reports get buried in email threads, completely isolated from future risk assessments. To compensate for these software silos, project managers are forced to act as human APIs. They spend hours manually transcribing numbers between out-of-date spreadsheets and accounting systems, chasing down context that should be available with a single click. The financial consequence of this manual transcription is severe. According to McKinsey, construction productivity has crawled forward at a rate of just 1% annually over the past 20 years. This chart highlights the exact cost of that fragmentation. Compared to the steep 3.6% upward curve of manufacturing productivity, the construction industry is flatlining. For a standard Swedish SME with 50 employees and 100 million kronor in turnover, that efficiency gap represents 3 to 5 million kronor in lost margin annually. The industry attempted to solve workflow issues by buying more software point solutions. Paradoxically, this proliferation of separate tools destroyed operational efficiency and created critical compliance liabilities. Recently, firms have tried to reclaim that lost margin by deploying generalist AI tools like ChatGPT or Claude. The results have been consistently poor. Horizontal language models lack the specialized domain logic required for Swedish construction. If you ask a generic AI to process an ETA change order, it doesn't know the critical legal distinction between an Ändring and a Tillägg. Instead, it hallucinates an approximation. These models operate in total ignorance of local regulatory frameworks. They cannot draft a legally binding offer because they do not understand the specific index rules of AB04 contract standards, nor can they cite paragraph 17 of the AFS 2023-10 workplace safety requirements. Furthermore, generic AI starts every query with zero context regarding the actual business. It cannot access localized material price lists, verify active ID06 worker certifications, or reference pending project schedules. In physical operations, approximation is physically dangerous. Asking a horizontal model to plan a traffic safety layout for a road closure usually results in a generic list of cones, entirely bypassing the strict, legally mandated requirements of the TDOC 2012-86 road safety standard. Enterprise software in highly regulated, physical industries cannot rely on horizontal approximation. It requires strict, localized vertical logic. Way of Work solves this by replacing the generic chatbot with a vertically native, multi-agent operating system purpose-built for Swedish construction operations. At the center of this architecture sits the orchestrator. The orchestrator is not an answering engine. It is an intent router designed to parse highly complex commands and distribute the labor. A user prompts, "We need a road closure, safety assessment, and invoice." The orchestrator decomposes this single intent into 4 highly specialized subtasks, routing each to a domain expert. By design, it never answers directly, strictly isolating logic to prevent hallucinations. True computational reliability comes from dividing high-stakes, multifaceted prompts into narrow, bounded specialist tasks. The first subtask is routed to the TA Planner agent. Enforcing TDOC version 5.0 standards, the TA Planner generates a schematic mandating 700 mm cones and T2 barriers. The structured sequence then hands this blueprint off to the Skadsombud, or safety representative agent. The Skadsombud agent runs an automated risk assessment on the proposed physical layout, checking for weather-aware constraints and required documentation. It cross-references APV safety certifications against the live personnel registry. Interlocking domain checks ensure an unsafe site condition is structurally prevented from passing the planning phase. The blueprint then flows to the calculator agent. The calculator references localized Swedish pricing standards, using secciones data to calculate exact labor hours, barrier rental fees, and equipment overhead. The fully priced estimate is then handed off to the facturering agent. This agent generates a mathematically precise invoice, formatted to ABO4 standards, and ready for immediate dispatch to the client via WhatsApp or email. At this exact point, the system hits a hard constraint. The workflow pauses at an API barrier before it can interact with an external client or alter a production database. This is the human-in-the-loop protocol. In physical construction, autonomous data mutation is an unacceptable liability. The AI cannot order materials without oversight. A human administrator reviews the compiled safety, costing, and invoicing proposals. They verify the logic and click Approve to execute the final change. The AI proposes the work, but a human ultimately executes it. This guarantees complete data sovereignty, auditability, and legal protection. Expanding outward from a single road closure, this connected architecture enables the entire enterprise to operate from a single, synchronized data state. Most construction firms suffer from institutional amnesia. When a veteran project manager retires or leaves for a competitor, they take decades of tacit knowledge with them. Pricing intuition, regulatory workarounds, and supplier relationships all walk out the door. Because Way of Work centralizes every action through specialized agents, that tacit human memory coalesces into a permanent, highly structured, and searchable operational database. The multi-agent system actively queries this new permanent memory. It analyzes historical pricing data to inform future ETA estimates and identifies patterns and safety near misses before an accident occurs. Automated tracking monitors the expiration dates of ID06 worker credentials, proactively preventing scenarios where a crew is denied gate access because a certification lapsed unnoticed. The operating system secures the company's most valuable asset, transforming vulnerable, undocumented expertise into permanent institutional memory. The full scope of the platform utilizes 14 distinct domain agents, including daily schedulers like schemaplaner and equipment logistics handlers like Machine Chef. Time tracking, safety compliance, equipment rental, and invoicing are finally reconciled into one central, version-controlled state. Project managers no longer have to navigate 9 disjointed software tools. The data silos are eliminated. Horizontal language models will continue to fail in physical industries because they lack the specific regulatory grounding necessary to keep workers safe and companies legally compliant. Digital transformation in heavy industry requires bounded, domain-specific AI networks, deeply integrated into localized rules and governed by human oversight.